Good morning. Today we are going to start a very basic thing, that is drugs acting on central nervous system. Already we have studied yesterday, but due to some inconvenience or technical glitches, what happened is that suddenly my microphone get muted, and because of that it is not audible properly. So today I am going to start again the drugs acting on central nervous system, mainly anti-anxiolytic drugs. I will study today completely from first to the last. In that I will tell you all the drugs, classification of drugs, their structural activity relationship, and along with that their chemical structures. Also I will mention the IUPAC name and what are the functional group present in the structure. Okay now. The thing is that if you feel like I am very slow, you can make it fast. If you are watching, recorded video, otherwise it's okay. You can watch at normal speed. Okay, so let's start from the very basic. First of all, drugs acting on central nervous system. So what are the drugs that acts on the central nervous system? Can you please tell me the classes of drugs that acts on central nervous system? So the classes of drugs that acts on the central nervous system are: number 1, drugs acting on CNS. Number 1, anti anxiety drug, that is called anxiolytic drugs. Anxiolytic drugs, also sedative and hypnotics. Okay, is it visible? Yeah, so let's start. They are anti-anxiolytic drugs. Next, number 2 will be antidepressant. Antidepressant. Next, number 3, what is that? Anti-epileptic. Anti-epileptic. Next, number 4, what is that? General anesthesia. General anesthesia. Next, number 5, local anesthesia. Next, number 6, opioid analgesics. Next, number 7, anti Parkinson. And number 8, anti Alzheimer drugs or agent. Yes or no? So these are the classes of drugs that mainly acts on the central nervous system. Now we were studying that anxiolytic drugs. Anxiolytic drugs or anti-anxiety drugs. So today we will start from the very basic, and we will learn all the classes of the anti-anxiety drugs and structure, classification, structure, and their structural activity relationship. Okay, before that it will be better if I can write there medicinal, medicinal medicinal chemistry. Right, is it visible? Yeah, good. So drugs acting on central nervous system. Let me write it properly. There, in that side, drugs acting on central nervous system. Okay, in that, first we are studying anxiolytic drugs. Anxiolytic drugs, right? So, can you please tell me something about anxiolytic drugs? Anxiolytic drugs are those drugs which reduces anxiety and stress. Now, if they are reducing anxiety and stress without inducing sleep, then they are called sedatives, and if they are reducing anxiety and stress with inducing sleep, then they are called hypnotics. Okay. Now the thing is that classes of sedatives and hypnotics. Number one is barbituric acid and their derivative. So number one, and what are the anxiolytic drugs? They are two types: sedative and hypnotics. Sedative agent and hypnotic agent, or you can say sedative drugs or hypnotics. So what are sedatives? Sedatives are those which reduce stress without inducing sleep. Whereas hypnotics are those which reduces stress and anxiety with inducing sleep. Okay. Any anti-anxiety drugs or any anxiolytic drugs in low doses it will act as sedative, and in high doses it will act as hypnotic. Okay, in high dose it will act as hypnotic. Now we will see the classes of sedative and hypnotics. So the classes of sedative and hypnotics, in this, how many classes are there? They are of approximately 10 class, but in general it is called 10 class, but they are actually 12 class. So what are they? Number one is barbituric acid derivative. Should I write? No, I will just tell you. Already I have written all these things in the previous last class. So I will tell you now. If you want to write, you can write. And actually we are revising that. So what are the different classes of sedative and hypnotics? Number one is barbituric acid derivative. Number two is benzodiazepine and their derivative. Number three, pyrazolyl pyrimidine. Number four, imidazolyl pyrimidine. Number five, cyclopyrrolone. And number six, piperidinone. Number seven, piperazine derivative. Number eight, parasympatholytics. Number nine, carbamate esters. What are the example of carbamate ester? They are meprobamate. So number 9, carbamate ester. Number 10, serotonin precursor. Number 11, chloral derivative. And number 12, miscellaneous. Right? Number 12 is miscellaneous. Now we will see all that. So number 1 is barbituric acid derivative. First we will see that number 1, barbituric acid derivative. So in barbituric acid derivative, what are the different classes of barbituric acid derivative? These barbituric acid derivative are of 4 classes. How many classes? 1, 2, 3 and 4. Number 1 is long acting. Number 2 is intermediate acting. Number 3 is short acting. And number 4 is ultra short acting. Is it visible? Yes. Okay, good. So long acting barbiturate or barbituric acid derivative examples are phenobarbital and mephobarbital. Number 2, in intermediate acting drugs, Example are amobarbital and alobarbital. Amobarbital and alobarbital. You have to remember this amobarbital is also called amylobarbital. It can also be called as amylobarbital. Okay. Next, short acting. What are the example of short acting drugs? Short acting are pentobarbital and secobarbital. Okay. Pentobarbital and secobarbital. And ultra short acting only one drug, and that is thiopen. I think the board is not okay, it is visible. Yes, it is visible. So that is thiopental. Okay, it's thiopental. Okay, it's thiopental. So let's start again. Now we will see each structure. See, before going to see the structure, first I will tell you the structural activity relationship of barbituric acid derivative and its structure or basic structural scaffold. So what is the structure of barbituric acid derivative or barbiturate? See, barbiturate is having the structural scaffold that is called pyrimidine. That is called pyrimidine. See, nitrogen, another nitrogen. Yes, what is that? This is pyrimidine, right? Now in this nitrogen it is having one hydrogen, this is also having one hydrogen. You will see 3 ketone group are also connected and there are 2 hydrogen, right? This is barbiturate. Now we will start numbering. So numbering will start according to OSNP. If you remember that or not, I don't know. What is OSNP? OSNP is the priority list for numbering a heterocyclic compound. Numbering a heterocyclic compound, right? So numbering will start from nitrogen. According to this, nitrogen is there, so numbering will start from nitrogen, right? Yes or no? So 1, 2, 3, 4, 5, 6. So how many members? 6 members are there. Now the most important point is that in the barbituric acid derivative you will see at 2nd, 4th and 6th position, that is at 2, 4, 6 position you will see 3 ketone groups are there. 2, 4 and 6 position you will see 3 ketone groups are there. And first and third position you will see 2 nitrogen atoms are there, right? At 5th position 2 hydrogens are there. Now what are the modifications can be done there? 3 modifications. What are that? Number 1 modification is modification on keto group. This is the number 1. Number 2 modification is modification on nitrogen. That is number 2. And number 3 modification is modification on 5th carbon. Modification on 5th carbon, that is number 3 modification. So 3 modifications are possible, right? So what are they? The first one is that modification on keto group at 2, 4, 6. So write that modification at 2, 4 and 6th position. If the carbonyl group, that C double bond O, that is called carbonyl group, this one, if that carbonyl group is replaced with thiocarbonyl group like this can be replaced with this one, yes or no? So if it is replaced by thiocarbonyl group, or it is also called substituted with, yes, oxygen is substituted with sulfur, then what will happen? Pharmacological activity of barbiturate will decrease. So in that case pharmacological activity will be decreased. Number 2 modification. Again another point I should mention that is very important, that if that carbonyl group is replaced with thiocarbonyl group, like this, then what will happen? This barbiturate will act as general anesthetics or general anesthesia. General anesthetic. Okay. Now the second modification. This is first modification. Second modification, what I am telling all this is a structural activity relationship. Second modification is possible on first and third position nitrogen. Yes or no? So in second modification, on nitrogen atom at C1 or C3, at C1 and C3 position, the alkylation on nitrogen group. That means if this hydrogen at second position, NH is there, right? So if this hydrogen is replaced with alkyl group, NR, this R can be CH3, this R can be C2H6 or C2H5 or anything like that. Okay, so if this NH group is replaced with NR group, that means alkylation on nitrogen. Alkylation on nitrogen atom at first and third position leads to decrease in pharmacological activity. So ultimately what will happen? It will also decrease pharmacological activity. Okay, up to this it is clear. Next we will see the third modification. What is the third modification possible? Third modification is possible at fifth carbon. So if at fifth carbon, what can be happened? In fifth carbon, two hydrogen are there, yes or no? If you see that two hydrogens are there at fifth position, fifth carbon. Now in the third modification, that is on fifth position, if two hydrogen atoms, 1 2, if two hydrogen atoms are present at the fifth position, then those compound having less pharmacological activity, that means if, see, fifth carbon C5, in that three possibilities are there. In that three possibilities are there. Number one, hydrogen, two hydrogen. Number one, two hydrogen. Number two, one hydrogen. And number three, no hydrogen, zero hydrogen. That is called no hydrogen. Rather, here there will be any alkyl group or anything. Alkyl group, phenyl group or anything. In the case of two hydrogen, the activity of the barbituric acid will be very less. It will be very less. In the case of one hydrogen, the activity of barbituric or barbituric acid will be less. And in the case of no hydrogen, when there is no hydrogen, rather if any other group, alkyl group or aromatic phenyl, like phenyl group, for example in phenobarbital, in mephobarbital, in that case what will happen? I will show you just now. I will draw the structure and I will show you. In that case, for example, the structure of phenobarbital is like this. Nitrogen is there, another nitrogen is there, like this, double bond O, ketone group will be there. So 3 ketone group, 2, 3, 2, 4, 6 position. Now here earlier 2 hydrogen was there, right? Now there will be one phenyl group, phenyl ring, and along with that one ethyl group. So this is that hydrogen is substituted with phenyl and the hydrogen is substituted with ethyl group, right? Yes or no? So this is called phenobarbital. That's it. Now if this hydrogen is again replaced, what did I tell you? Again another modification that can be done in hydrogen, in the nitrogen, that hydrogen can be replaced with any alkyl group, that is alkylation on nitrogen. So now if a CH3 group, methyl group is added there, now it is called mephobarbital. That's it. Structures are very very simple. You have to remember, just you have to understand everything and you have to remember properly. Okay. So this is called mephobarbital. If this methyl group is not there, this is called phenobarbital. Okay. So if at fifth position these hydrogen are substituted with any alkyl group, then activity will be more active. It is called more active. It is less active, and that is very less active. Okay na? Up to this it is clear or not? Up to this it is clear or not? Tell me, up to this it is clear or not? Okay. Now we will see each and every individual structures. Okay. So this is, you can write it as SAR. Okay. 1 second please. Now we will see the individual structure. So first we will start from phenobarbital. Okay, already I told you about phenobarbital. This is phenobarbital only. This is the structure of phenobarbital. And also if we add that, if we replace that hydrogen or alkylation on nitrogen with CH3, then this is called mephobarbital. So what is the difference between phenobarbital and mephobarbital? Now I told you one very important point, and that is, see, there is alkylation on nitrogen, that is second modification. Then addition of phenol or substitution of hydrogen with phenyl ring is which type of modification? Third modification. Okay, this one also you will see in the last one. In the last one means this one, thiopental. In thiopental what will happen? The structure will be like this. See, everything is same, only in the case of oxygen, here you will see one sulfur will be there, and thio means sulfur, right? But what is that pental? Why it is that compound is named as thiopental? So thio is given because of sulfur, and pental is given because of presence of 5 carbon there, 1 2 3 4, right? So the structure will be like this. How many carbon? 1 2 3 4 5. So 5 carbons are attached, yes or no? That is called isopentyl group. What is that? Carbon, 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 and it is connected with some other circular structure, cyclic structure, and there is another carbon, right? So this is isopentyl group or not? 1 2 3 4 5. Isopentyl group or not? Yes, this is isopentyl group, and because of this pentyl ring or isopentyl chain, this compound is named as thiopental. This compound is named as thiopental. So in this way you can understand all the structures, and you can remember also, if you will understand how the compounds are named. So naming of compound, understanding the naming of compound is very, very important. Okay, so phenobarbital and mephobarbital already completed, right? I hope so. Next thing we will see, that is intermediate acting. Who are intermediate acting? Amobarbital and allobarbital. Again I will tell you, see, it is also very simple. Barbital means, first of all you have to draw the barbituric acid structure. So this is barbital, right? Yes or no? Here one nitrogen is there. Yes or no? This is 2 4 6 trioxo barbituric acid. Yes or no? Yes. Now what will happen? Why it is called amobarbital? Because of the presence of amyl group. Because of the presence of amyl group. So where is the amyl group? 1 2 3 4 5. Okay, modification is done at 5th position, and along with that you will see one ethyl group present. So this is ethyl group, this is amyl group, and because of this amyl group I will write one thing. Isopentyl group, this one is ethyl group, and this is also called amyl group. Because of this presence of this, it is called amobarbital. Okay, remaining everything is same, numbering 1 2 3 4 5 6. Okay, am I clear? Now we will see allobarbital. So what is allobarbital? In allobarbital you will see one allyl group will be present. Barbital is same, barbital, but allo means allo came from allyl group. So now you will see one allyl group will be present there. See, allyl group, do you know the allyl structure? What is called allyl? Allyl means, see, this double bond, this is called allyl group. Yes or no? Allyl. So there will be a double bond present on the 5th position. Ultimately substitution is done at 5th position. And what is the structure? Structure of allobarbital is like this. Two double bond. So what are the two double bonds? Number one is this one, and number two is this one. This is called allobarbital. That's it. Allobarbital. Am I clear? Yes or no? Do you have any doubt? If you have any doubt up to this, you can ask me. Next we will see the structure of short acting benzodiazepine. So what are the short acting benzodiazepine? Pentobarbital and secobarbital. Again, barbital means the barbituric acid structure, it will be same as it is, the structural scaffold, it will be as it is. Now the changes will be at 5th position, or that modification will be done at 1 2 3, that already I have told you, right? So in the case of pentobarbital, what will happen? There will be 5 carbon, and along with that 5 carbon, one ethyl group will be there. 1 2 3 4 5 carbon, along with that one ethyl group will be there, that's it. So this is C2H5, right? This is C2H5, and this is 1 2 3 4 5 carbon, that is connected with chain ring, that cyclic structure. If you want to write the name, you can also write the name, that is isopentyl. And that is what it is called? Ethyl. Now it is called not allobarbital, it is pentobarbital. It is pentobarbital. Simple, very simple, short and sweet structures. Now secobarbital. Now I will tell you the secobarbital structure also. It is also very simple. In the case of ethyl, now everything will be same. In the case of ethyl chain, you will see one allyl chain. Now it is not ethyl. Now it will be 1 2 3. What it is called? It is allyl. Yes or no? Already I have told you just 2 minutes ago. So presence of allyl and isopentyl group will make it secobarbital. It is called secobarbital. It is visible or not? Yes, it is visible. So it is secobarbital. So structures are very simple. You need to understand just how it is given, or how the names are given. Again, thiopental. Already I have shown you the thiopental structure. In that also barbituric acid structure, that is basic structure, that is structural scaffold, it will be as it is. The modification will be at 5th position and 2nd position. So in 2nd position, what will happen? Thio means sulfur, so you will see one sulfur there, and pental means 5 structure, 5 pentyl group will be there. Yes or no? Pental means 5 carbon structure will be there, or pentyl ring will be there. So 1 2 3 4 5, that's it. And along with that you will see one ethyl group. Yes, and their structure, that's it. It is called, now it is called thiopental. Okay. So the structures are very simple, you just need to understand how it is written. Now barbituric acid derivatives are completed. Now we will see the 2nd class of sedatives and hypnotics. So what is the 2nd class? The 2nd class is called benzodiazepine. So first of all we will see the structure of classification of benzodiazepine, then SAR, and then structures as same as barbituric acid. Okay, let's start. So now it is not barbituric acid derivative, now it is benzodiazepine and its derivative. So what is that? It is benzodiazepine. Benzodiazepine is denoted as benzodiazepine. It is also denoted as BDZ. Okay, it is also having 4 classes. What are the 4 classes of benzodiazepine? Again same, long acting, intermediate acting, intermediate acting, then short acting, and then ultra short acting, as same as barbituric acid. Now what are the examples of long acting benzodiazepine? They are diazepam. Number one is diazepam, then chlordiazepam, then clonazepam, and then flurazepam. Again I will show you the structures. These are very simple. Only in clonazepam chlorine will be there, in flurazepam fluorine will be there, like this. Okay. Next, what is the intermediate acting benzodiazepine? It is very simple, that is nitrazepam. See, in intermediate IN is there, right? So whenever you are writing the drug, you have to change that NI. So what is that? Nitrazepam. What is that? Nitrazepam. And next is alprazolam. That alprazolam is very very important because of the presence of the 1,3,4 triazole ring. Okay, alprazolam 1,3,4 triazole ring. It is very you have to put 5 star on that alprazolam. So many times the question are asked in the different competitive exam about alprazolam because of its 1,3,4 triazole ring. I will tell you later. Next is short acting benzodiazepine. So what are the short acting benzodiazepines? SHOLT, salt acting benzodiazepine. O for oxazolam, O for oxazepam, L for lorazepam, and T for temazepam, Okay. Next is ultra short acting. Ultra short acting are, in ultra short acting T is there, right? T is there. So ultra short acting is triazepam, not triazepam, it was I think triazolam. Yes, triazolam and midazolam. That triazolam structure is also very very important because of the presence of the 1,3,4 triazole structure or 1,3,4 triazole group. Now I will show you what is that triazepam and triazolam and what is that 1,3,4 triazole group and everything. I will tell you, I will show you. Okay, let's see the SAR or structural activity relationship on the left side, and then in the sorry, one second. Sorry for the inconvenience. Actually, I am having little bit health issues, and because of that, cold, cough, fever, everything. Actually, on the 1st January, I went out for some enjoyment. One second, let me check whether the sound is coming or not. Okay, please wait for 1 minute, 1 second. Wait a second, please. Actually, same thing happened yesterday. Suddenly, I got some coughing and all this. Then I went out, and when I went out, what happened is that I muted the microphone, and again when I came back, I think I forgot to I forgot to unmute that, or what, I don't know exactly. I forgot that. But what happened is that after the coming back from outside, I have started continuing the class, and when I ended the class, then I checked, and I was shocked that the sound was not coming after that. That's why today I have to check first. I have to verify whether the sound is coming or not, and then I'll start. That's why today I have to check first. Yeah, I have to verify whether the sound is coming or not. Yes, it's coming. And then okay, let's start. I'll start. That's why. Sorry for the inconvenience. Let's start, everyone. So now we will see the structural activity relationship, that is SAR of the benzodiazepine. Okay, and this benzodiazepine is very important. You have to understand that. So many questions every year. One question comes from benzodiazepine. So this benzodiazepine structure is very important. You have to understand that. Okay. Now see how I have shown you earlier. In the same way, again I'll show you that this benzodiazepine structure also you will never forget. Why? Because already the name is itself is telling you the structure. What is the structure? First, benzo. Benzo means there will be a benzene ring, 110%. Yes or no? So benzo means there will be a benzene ring. So first draw the benzene ring. First draw the benzene ring. This is the benzene ring, right? No, this is cyclohexane. So what is the benzene? Yes, this is benzene ring. Again, benzo means benzene ring. Diaza. Okay, benzo diaza pines. Pines means ep ein. Yes, so benzo means benzene ring, di means 2, aza means nitrogen, ep means 7 membered structure, right? Ein means there will be any NH or NH2 or anything like amine group. Okay. So number itself, that name itself is telling you the structure exactly. So benzodiazepines. So in this, benzo means benzene. Now this benzene is connected or it is linked, or what it is called. It is fused with the diazepine ring. So 1 nitrogen, 2 nitrogen. See, in the diazepine structure, how many members are there? Let's see. 1 member, 2 member, 3 member, 4 member, 5 member, 6 member, 7 member, right? So 7 member means yep. Do you know how to name that heterocyclic structure? I don't know whether you know or not. If you don't know, then please comment below. Next I will tell you, or in the next class or anytime I'll make some time and I'll take a small video. In that I'll tell you how to name that heterocyclic structure. Okay. So in the benzodiazepine, see, benzo, diaza means 2 nitrogen, ep means 7 member. When the structure, when the ring or the structure will have 7 members, it is called ep. Ep means 7 member ring, and ein means nitrogen. So this nitrogen is having a hydrogen, or this one is having hydrogen, like this. So here that one is having hydrogen, and there will be a unsaturated bond, and after that there will be another phenyl ring. Okay. At 7th position there will be one R. At 7th position there will be one R. Numbering will start from which side? Numbering will start from which side? Please tell me. According to ISNP, numbering will start from first. I don't know, you people are not commenting also. So numbering will start from there. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So the thing is that why didn't I number these two? So you have to remember, when there is any bridge atom or bridge carbon, that fused carbon, both the ring are fused in that two carbons, right? So this fused carbon or bridged that atom is not numbered continuously, it should be numbered in different way inside the bracket. Okay, so numbering will start from nitrogen according to O, S, N, P. Nitrogen is present there, so nitrogen will be more prioritized. So from nitrogen 1, 2, 3, 4, 5, 6, 7, 8, 9. Now the most important thing that you have to remember is that at 7th position one electronegative group should be there, highly electronegative group. So why? Because this highly electronegative group will, what it will do? It will activate the cyclic structure, and when it will activate the cyclic structure, the benzodiazepine will show its exact function. So can you please tell me now how many fragments are there? This one is a part of this benzodiazepine. This is not the different ring. You can't consider this as a ring. In the structural scaffold, how many rings are there? 2 ring. 1 ring, 2 ring. Ring A, ring B, right? 2 rings are there. So these two, because of the 2 rings, this is also called bicyclic structure. So this is also called bicyclic structure. What is bicyclic structure? Benzodiazepine is an example of bicyclic structure, and bicyclic structure means this structure is composed of 2 cyclic ring or 2 cyclic ring. Now the thing is that this is a branch, not a branch actually, this is a part of ring B. The main ring is A and B, that's it. Now what are the different modification possible? The first modification is possible at ring A, second modification is possible at ring B, third modification is possible at ring C. Also modification possible, it is considered as ring C, but it is not a part of complete structure, it is a part of this one. I think you are getting confused with this. Simply you consider like this. This is the benzodiazepine structure. It will be better. This is the benzodiazepine structure. In that, for example, this nitrogen will be having hydrogen. If sometimes any substitution or modification is taking place, then this hydrogen will be changed with alkyl group, right? CH3 or something. In the same way, there is a carbon in the 5th position, yes or no? In the 5th position there is a carbon, yes or no? Yes, there is a carbon in the 5th position. This carbon is having how many bonds? 4 bonds. Why? Because carbon are having 4 valency. So this is the 1 bond, this is other bond, this is third bond, and where is the 4th bond? So there is a 4th bond. This 4th bond is connected with hydrogen, yes or no? Now in general this carbon is having 4 bond, and if 3 are connected with any other things, 4 one is in general connected with hydrogen if nothing is mentioned. But here this hydrogen is simply replaced in the way that hydrogen connected with nitrogen was replaced in modification. In the same way this hydrogen is replaced with a phenyl ring. Okay, so you should not consider this phenyl ring as a main chain, but you can consider it as a sub chain. The main chain are A and B. In that ring again, if we can connect any electronegative group here, again it will also show the effect inside the ring. Why? Because of the resonance. See, double bond sigma double bond, like this will something resonance will happen there. Okay, resonance is different, that is in GOC 1, general organic chemistry 1. I will explain you later general organic chemistry also. If you want that, please comment below. Now this is the exact structure of benzodiazepine. So what are the modification, or how many fragments are there? 3 fragments. What are the 3 fragments? This is the fragment 1, this is the fragment 2, and this is the fragment 3, right? In fragment 1 or ring A, modification possible. In fragment B, ring B, modification is possible. In fragment 3 or ring C, modifications are also possible. Okay, 1, 2, 3, ring A, ring B, and ring C. In that, what are the modifications possible? I will tell you very simply. Just see. Just see that. 1 second. See. What are the modifications possible? Ante means, see, this nitrogen is having 1 hydrogen, yes. This hydrogen can be replaced or substituted with any alkyl group, possible or not? Yes, it is possible. Second, this phenyl ring is having at ortho position. This is ortho position. What is ortho? For example, this is alcohol. this is alcohol or phenyl group. This is called ortho position, this is called meta position, this is called para position. OMP, ortho meta para position. Okay, so in that ortho position, if any electronegative group can be added, it will increase the activity. So in this also modification possible. So any electronegative or any alkyl or anything can be added. In the 7th position also, any electronegative group should be present. This is must needed and it is very important for the activity of the benzodiazepine. Okay, am I clear? Now I will show you the structures, but before showing the structure I will ask you a previous year question. Which of the following is highly